Hey, 2.8, proportions and similar figures.
Ooh, I love this
Me
stuff.
too.
It's fun. Okay, guys. So, similar figures have the same shape, but not necessarily the same size.
Right.
So, as you can see, we've got two triangles. They're similar.
Yep.
They're not the same size.
Right. One's bigger, one's smaller. There you go. Similar. Here it is, guys. I mean, I don't know what else to say. There it is. This is just saying that what we mean by similar is that angle A is congruent. That symbol means congruent to angle F.
Congruent means same, equal.
Yes, and do you know how to write that?
I do. A squiggle.
I love it.
If you're in the building, please call 6002.
There you go.
Corey, please call 6002.
Line, oh,
No.
there you go.
Mrs. Tauchis, could you please come back to your office?
She's-
Mrs. Tauchis, please come back to your office.
She'll be
Nurse.
there soon.
Nurse is on her way. Okay, so here, this is just asking, we're not doing this in our homework, but this is just showing you that we have sides that are congruent and we have angles that are congruent or corresponding.
Not
Okay?
well, there's corresponding angles and corresponding sides. Sometimes they're not congruent if they're not the same size.
Right. So
this-
angle A,
That should go under angles.
man, I tell you what.
Oh,
maybe I need to go see Mrs.
Mrs.
Tauchis.
That's why she's going to her office.
Angle A is congruent to what angle, Richardson?
D,
D.
because they're both in the same location on the triangle.
Right.
Okay. Okay. So then angle B is congruent to, but we're not supposed to be talking about congruency on the. Well, it's congruent because they're the same angle.
Right.
Okay. And then we also have angle C is congruent to angle F, but they are also corresponding, which is what we're ultimately wanting to get to is
Right.
the corresponding. They're in the same location, so that means they're corresponding.
Correct.
Okay.
And then we have sides. So if I have side AB, so to write that, you have AB and a line over that.
Mm-hmm.
That is congruent to what side
It's
or
not-
corresponding?
But we can't say we can't say that's not, we can't say congruent, right?
Okay.
My gosh. AB,
Is equal to?
I think you just do one squiggle, corresponding, right?
One squiggle.
Mm-hmm.
Okay. Hang tight. Line AB.
There you go.
Okay.
Is corresponding to.
DE. You have to go in that same order.
Mm-hmm.
DE.
Got it.
Okay.
Okay, so then let's do another side. We've got side BC is congruent to, no, is corresponding to EF. And then the other one is AC, congruent, nope, corresponding
There you go.
to DF.
Okay.
So again, they're just in the same spot on the triangle.
Now, the same thing applies. Let's say that this triangle happened to be this way.
Oh, it's flipped.
Okay? It's still flipped, but you have to look at, maybe I'm doing this right.
Yeah.
You just have to look at still the location.
Well,
So F is still out at this little point, and C is still out at this little point.
yeah, the D and the E are the wrong. Is there only one way to write a proportion? Is there only one way to write a proportion? No, you can, well, that was,
No.
okay.
Thanks, book.
Okay. I bet it says no there too.
Yeah.
Okay, find the length of side. So we're going to use corresponding sides and what we know about scale factor to find the missing side, right? Oh, no,
Right.
we're using proportion, sorry. Okay.
Here's the same question again.
Okay, so we're going to set up a proportion with corresponding sides in the same spot in the proportion. So what is side DE?
So
So,
my unknown is DE. So I'm going to put an X there to identify my unknown.
okay, so X over 10.
X over 10.
And then we're going to do the corresponding sides of those in the same location on the fraction that are on the other triangle over there. So 4 and 5. So the two, actually those are hypotenuse. What is a hypotenuse?
Well, no, hypotenuse.
Okay, so the hypotenuse
The long guy.
of these right triangles correspond to each other. So that's why their quantities are in the denominator. So then we just use this to solve.
Right, and this is what we did last night. So 5 times X
5x,
equals,
4 times 10 is 40. I always drew arrows like, anyway, doesn't matter.
I did that last night.
You did.
Oh yeah,
Okie dokie.
you haven't watched me on the flip side.
I have not.
Okay,
40 divided by 5 is 8.
done.
So that means that side
X,
DE
yeah, DE.
is 8.
There you go.
And it doesn't tell me centimeters or anything. Okay, cool. Okay. You can also use proportions to do indirect measurement, like finding shadows and stuff like that.
Right.
So, a student who is 5.25 feet tall is standing next to a tree. I hope it's not lightning outside,
Right.
because he's going to get hurt. Okay, the shadow of the student is 20 feet, and the shadow of the tree is 80 feet. What is the height of the tree? Now, I always draw pictures.
I do too.
Oh my goodness.
I do too.
Witterson,
Here's our guy.
and he's got a line, and he's 5.25 feet tall. What are you doing?
Well, I need to draw his height, but man.
Just write it.
right here.
Yeah.
Okay.
And then he's got a shadow coming out.
So would a shadow be down?
Yeah, it's gonna
Okay.
be right there, on the ground.
Mm-hmm.
And we know his shadow. Oh yeah, it's 20 feet.
Okay.
Okay. Then we've got a tree. Guys, we need to see this picture on your notes, and we're judging on how good your tree looks. It better look that good.
Mm.
Okay.
Sorry about that.
That's an oak or
Okay.
something. I can just tell.
It is.
Okay, the tree, we don't know how tall it is,
Okay.
so we're solving for x there, and it has a shadow of 80 feet. 80. Cool.
These are not to scale.
Mm.
Okay. Not to scale.
Disclaimer. Okay.
So now we need to make it a triangle. So connect.
Don't really have to, but
Do it.
do it anyway.
Okay.
And then now we have corresponding sides. So
And guys, we're not kidding. We actually draw a picture
Like,
with these type of things.
literally, like I do this still.
Yeah.
So we're gonna put 5.25 on top.
Okay. Do you want us to start with x first?
Sure. Okay. So x over 80 is the same as this picture, which is 5.25 over 20. You probably can't see. There you go. And now we solve.
Yep.
Okay. X times 20 is 20x. And 5.25 times 80, I don't know.
Come on. For it.
Boy, there
Yeah,
it is.
It's like I knew I pressed
Okay,
it.
5.25 times 80.
420.
420. Divide by the coefficient.
Coefficient, guy in front of the letter.
X equals
42 cut in half.
21
21 what?
feet. Awesome.
Done.
The end. Aren't you glad you know how tall the tree is, guys? Okay, interpreting scale drawings. So this is totally legit. You don't
Yeah.
have to read maps and stuff. 1 inch represents 12 miles on a map. If the distance between two buildings is 4 inches on the map, what is the actual distance? So 12 miles is equivalent to 1 inch
So 1 inch
on the map,
over.
12 miles. And look at, you have it in the star there, I didn't even notice.
Bingo. So map over actual distance
Is equals the other map over actual distance.
So like we talked about last night, you have to have the same items on top and the same items on bottom.
So 4 inches between the buildings on top.
And if you're confused on where to put this 4 inches, well, the label of inches needs to go on top.
In the same spot. And then X.
There you go.
And now we solve.
So 1 inch times x, easy peasy.
X,
4 times 12.
48. You wrote, oh yeah. So is this going to be miles or inches? Miles.
Because that is the location of my x.
Mm-hmm.
So one thing that we can't get lazy on, guys, is
Labels.
labels.
Mm-mm.
Even here, labeling while you're doing the problem.
Because if we didn't have those, you guys would be like, oh, what's, I don't know what it is.
Quit crying. No crying in Witterson.
No. That looks like my college campus.
There you go. It is.
Oh, it says a model of a new campus building. Okay, so we're going to do it again.
Okay.
So, a model of a campus building is 5 inches tall. If 1 inch represents 8.5 feet, how tall will the building be?
So this one doesn't come out and say our scale model is, our key is.
We have to
So-
make it ourselves.
Yeah, we'll just interpret it.
Okay.
So it tells us that 1 inch is 8.5
Mhm.
feet. Well, I have 5
5
inches,
inches.
so would that go on top or bottom?
Top, because that's where inches is.
How tall will the building actually be? So that's our actual.
X amount of feet. So, and now we solve.
1 inch times x,
Is X.
5.
8.5 times 5. It's 40 point something. No, it's going to be like 44. 40, I don't know, just do it. I don't want to think. 42.5 feet.
There you go. Done. See? Isn't this fun?
Easy.
Isn't this fun?
Okay, it is fun. Okay, so we are going to do this lesson check.
Mhm.
Tomorrow we will go through them, but you need to try them on your own.
Yep. And don't forget to label as you're going through it.
Well, duh, and half. Okay, we'll see you on the flip side.
Later.